Hey everyone, my name is Dax and this is Jay. We work on a framework called SST. SST helps people deploy pretty much anything, but instead of focusing on DevOps teams that already know to do this, we focus more on application developers. With how powerful and capable the cloud has become, it's pretty useful for application developers to have direct access to it, but they're not familiar with things that we might consider table stakes like infrastructure as code. The first two versions of our framework were built on top of AWS CDK, and over the past 6 to 7 months, we have transitioned entirely ground up rewrite to Pulumi. So we're going to talk a little bit about that process. Yeah, so I guess I wanted to start with like the initial scope of what SST was going to be. So the first version of SST was built on top of CDK, which was a transition from what came before. So what was like the idea of the initial scope and what was going to be different about this thing?
Yeah, the initial scope was specifically for serverless developers, so using Lambda or API Gateway or any of the sort of serverless resources on AWS. And what came before was a serverless framework or sort of similar tools that were built on CloudFormation. And in some ways, they were a not an abstraction, but a simplified version of CloudFormation. So CloudFormation has effectively every single resource that AWS has, but there's only a subset of that a serverless developer cares about. And on top of that, there are only a few set of properties, I guess, that a developer cares about in their day-to-day experience with it. And so what we were doing was we were taking that, using CDK in this case, giving people sort of higher level components. So giving you that simplified view of these resources, but also giving you the ability to drill down and be as complicated as you want it to be. So that's sort of one part of it. And the second part was giving you a really good local developer experience for a serverless developer, which isn't quite related to CloudFormation or Pulumi or Terraform, but it was more to do with the fact that the way people were building on Lambda was just fundamentally kind of broken, and that was what we were trying to solve. So those were the two things we were trying to do.
Yeah, so on that first side, so the previous things that existed, like service framework, you can probably even lump Terraform and a bunch of other things in that category, basically helping you spin up these resources you need. These are things that I think historically an application developer could have kind of ignored because they just work on the application and they hand it off to a DevOps team that will figure out how to get it deployed. With the more serverless stuff, which I guess it makes sense why we started there, that's where the developer starts getting a lot more exposed to infrastructure things because on the day to day, they might need to spin up more functions or more queues, whatever it is. And it's hard to do that in a way where they just hand it off to some of their teams. So giving them tools to directly use that is good. I think the twist is application developers are typically writing their stuff in their editor using a programming language. And all the existing tools were kind of configuration based. The serverless framework is YAML based. Terraform is their own thing. So that shift, the serverless framework YAML to, again, the first version of SST, which was built on top of CDK, so you write in TypeScript, was at that time, was that like a weird shift or did people want that? Like, were you like worried that people weren't, that wasn't going to click with people? Like, I don't know if you remember.
Yeah, I don't think we were quite worried that it was going to click with people. I think it was more natural for a lot of people because coming back to kind of like this higher level components thing, if you worked on a serverless framework or the Terraform one, it could be a little bit different, but serverless framework or this like AWS had their own thing called SAM. If you worked on it long enough, you would get into the scenario where a really large part of your infrastructure definition just turns out to be CloudFormation. So, you might have started in a place where you're pretty much not dealing with it directly, but you end up in a place very quickly where you are doing basically just that. And that was something, again, from a developer's perspective, was not what they had signed up for. From their perspective, it was like, hey, I'm writing some code, and yeah, there's like a config file, but it's a tiny config file. And if you spend enough time in it, what happens is that tiny config file just turns into a giant definition file, because again, you're dealing with every single resource and every single property. And now you're doing these two things, and then it comes down to, oh, I wish I had a better way to kind of deal with that. with that part of it. And so I don't think we were quite worried about, will they get writing infrastructure in TypeScript? Again, partly because our audience was one that wasn't looking to do that to begin with. They were incidentally working with infrastructure as opposed to intentionally working with infrastructure.
Yeah, that makes sense. Yeah, this reminds me, I think a lot of products kind of go through the same problem. I think a really classic one is there's so many products that help you build internal tools, like Retool, for example. And at first, it's really nice because it's like this drag and drop UI thing. It's in its own little bubble. The idea is someone non-technical can put this stuff together. But inevitably over time, it does end up being something that engineering has to take care of. And now suddenly you're like in this weird world and spending more and more time there, which is totally different from what stuff looks like day to day. So I think a big part of SST is to make it so your day to day, whatever your tooling looks like, you don't have to eject from that to go and work on infrastructure. It just feels like a continuation of the same thing. And I think initially CDK gave us that ability because, it had the capability to spin up AWS resources using TypeScript.
Yeah, and our sort of higher level components would make it so that day one, you don't have to think about everything. And then over time, you're sort of gradually introduced to the concepts.
Yeah. So we made it basically 2 versions building on top of CDK, and our upcoming version 3, which we're going to launch next week, has completely shifted ground up rewrite built on top of Pulumi. Yeah. So like, what is your like memory of starting with CDK and kind of like having to move off of it? What was that transition like?
Yeah, to be honest, I think when we had first started with CDK, obviously we were aware of the Terraform ecosystem and even Pulumi to a certain extent. But there were, I'd say, 2 things that kept us there, kept us in the AWS ecosystem. One was just the thought that we didn't think we were going to expand out of AWS until a while later, mainly because, the serverless ecosystem itself was far more fleshed out in the AWS world, and it seemed like that's what AWS really cared about, especially when you compared it to sort of Azure or GCP. Obviously, things changed when we started playing with Cloudflare, so that became a little bit more urgent. So that was sort of one side of it. And the second was, if you're thinking that you're going to be in the AWS ecosystem, you just want to use AWS tooling. So this hesitancy to try out and solve some of the CDK problems we'll probably talk about was always sort of put off by the fact that, look, if we're going to be in the AWS ecosystem, you probably want to be as AWS native as possible, even though on some level that there are some fundamental flaws with CloudFormation and CDK eventually. So that's kind of where we were. And I think that's probably what led to a lot of the friction, even though I remember, you had tried out alternative versions of like a different engine outside of using CloudFormation fairly early.
Yeah, it was like almost immediately when I joined. I think in the first couple months we were even just kind of talking about the potential of not using CDK. I think what also kind of may not necessarily changed, maybe as projects using SC matured, we saw the reality, which is even if you're primarily on AWS, you still have random things minimum here and there that is not on AWS. So again, having to eject out of the pattern you're used to go handle that stuff just wasn't great. So I think that was a big driver for me. There was a lot of exciting stuff happening outside of AWS. Like, so Cloudflare is one, but also if you wanted to use a database provider that was external AWS, suddenly you're like stuck managing that in a more traditional way. So I think a lot of people, when we started talking about that, they were like, oh, this is like multi-cloud, which I think it maybe technically is because you're using a lot of different resources, but it's not trying to create a single abstraction that like can go between different clouds. It's more just giving you a consistent way of accessing everything, no matter where it exists. Not like abstracting that at all. Like you have direct access to all of it, and you can use it in the way it's meant to be used. And yeah, I think like over time, us personally, like we wanted to use stuff for our projects that was outside AWS, so we had that driver. But then, just seeing how much was going on, not being able to be a part of it, like I think that just was painful the longer that went on. So that's one side, just like capability side wise. But I think even outside of that, we just had a bunch of problems with CDK and CloudFormation. I think that some of those problems seem like they're related to trying to build a framework on CDK, but ultimately they are all problems that end users eventually run into. So we were kind of like a super user of CDK in a lot of ways, because we built really sophisticated components with it. We like used every single feature. We tried to handle all sorts of edge cases because people use our components in different situations. And we found that like the traditional IAC approach, where you define something, it generates an intermediary format, and that intermediary format is executed. That works for a lot of things. I think like for traditional infrastructure, that is something a DevOps team would be handling. That works. But if you're trying to give these tools to application developers, there's really complex stuff that happens, right? You might have a framework you're using in your application language. You might need to build that framework. Depending on what that framework outputs, there might be certain infrastructure you need to deploy or change or whatever. So I think we were really realizing that we couldn't have this simple like generate deploy step. We need something a lot more dynamic, where part of the deploy can start and finish, and that could trigger later parts of deploy. It's kind of like the typical like graph structure of defining like all the dependencies. And we didn't for a while even know that Pulumi was different. I think for a long time we just thought Pulumi was the same as everything else, which is it just generates Terraform or something and then runs Terraform deploy. But it's actually a full deployment engine that was kind of capable of all these really advanced things, which to me was interesting because I was like, who needs this besides us? It really felt like it was
right,
like really built for us with us in mind. But I think that's just a good fundamental design.
yeah. I think the fundamental design does end up, and it's like you see that over time as you like use it, because it has these far-reaching consequences on, in our case, like your end users. It's not just us; it's like our end users, and a lot of it is that it's a far simplified model on some level to understand and use. It's funny. I think we've talked about this maybe publicly, how the value of having everything in code, and how working with regular code as opposed to like a regular programming language as opposed to a definition file sort of helps you do things that you're normally comfortable with. I think one of the downsides that comes with having everything in code, like TypeScript, let's say, is that you have the typical engineering problems of you could over design something, and CDK on some level felt almost over designed in the wrong parts. And Pulumi, on the other hand, I think one of the things, it's like the inputs are just sort of just like standard inputs that you would expect, as opposed to, oh, I feed a class into another, or like like I'm dealing with like your class structure, which again, like CDK compounds this by the fact that you have that, and then it outputs sort of YAML or JSON, right? And it's not directly doing things, so it makes it worse. But it's interesting, when I was thinking about this the other day, when I realized that your code gives you this ability to be really expressive, but doesn't always mean it's a good thing. With CDK, that felt like it was the design was a little bit off.
Yeah, it's funny because now that you bring that up, I've like forgotten all this stuff. It's like nice to forget all of these things. Like I became such an expert in CDK because there was so much to be an expert in, because the internals were really crazy. Anytime you saw any kind of object and you would try to understand like how it worked, there was 8 layers of inheritance behind it. So yeah, it was quite challenging working with that. And I think this is some of the criticism that infrastructure as code done as a programming language gets, which is it gives you too much power. And I think some of the nice side of something like Terraform is it's just a config language for the most part. So 2 different people writing Terraform, the output's going to be very similar, whereas code lets you do like crazy abstractions and like create new patterns and a lot of that. So we have seen pretty wild things, even among our user base. People do kind of go a little bit crazy with it. I think what's been good about Pulumi is there's just like a few primitives that exist in it, and you can pretty much compose them together to do pretty much everything. It's not already like encouraging you to go crazy with it. It's like, look how much we can do with so little. There's just basic resources. They all take primitives as inputs. You don't have to like import a class from here to pass it to a field there, which if you're a Pulumi user, that just sounds like weird. Why am I even bringing that up? But CDK was very complicated by comparison. There's the output system, which is maybe a little bit challenging to get a handle on initially, especially if you're new to that style of programming because it definitely
Yeah.
comes from more the functional side of things. But once your brain like adjusts to that, yeah, just resources, the output system, and components. And with those three things, you can kind of build everything. You can do all these complex graph things that I was talking about earlier. So yeah, it just feels way more like there was a process by which a lot was shed and they figured out how
Yeah.
to do the absolute minimum. Where CDK more feels like they were given a target and they just went really hard at it for several years and built and wrote a lot of code and resulted in a lot of complexity. And it's just weird. And this always happens with good products where there's fewer concepts and then you can do more with it.
Yeah.
And that's how you
Yeah.
know you kind of hit on the right design.
Yeah, yeah, yeah. It's like I think CDK on some level gives you like almost a fake sense of power, and I think that that sort of hurts you in the long run. I was thinking about this the other day as well, is that in some ways, especially the config that we have now with the Pulumi design, is it's almost like a subset. We almost want to guide you towards using a subset of what TypeScript can do. Like
Mhm.
it's not like I think it's a mistake to almost go the other way and be like, oh, it's like fully expressive. I should probably counter that by saying fully expressive in the CDK world, given that it's an intermediate step, I think is worse.
Yeah.
It's you can quickly get into problems because again, like sure, like outputs are sort of harder to sort of figure out the first time you use them, but in CDK world, like you can't even see them, right? Like it's an intermediate step, so that makes it even trickier.
Yeah. And I think that was a lot of the tough spot that we were put in that our users, yeah, some of them are CDK users that switch to SST so they understand some of these things, but a lot of our users are SST users. And when they ask
Yeah,
us questions like, hey, I got, this resource gives me this URL, but like I need to drop the HTTP port because I want just a domain name. How do
yeah,
I do that? It looks like
yeah,
normal code. It looks like a string, and they go
yeah,
and they console log it and they get some like crazy token. And these types of things are so hard to explain from our position because we wouldn't have designed it that way. So
yeah,
we're like explaining someone else's design choices. And I think this just started to like compound. We had 100 of these things,
yeah,
and SST started to feel like a bad product because of like the conflict that was there. Yeah, that thing where and this is subtle and maybe a little bit hard to understand, but once it clicked for me, this is kind of what like really defines the difference. In a lot of these other tools, your program is a code generator. Like when you write
mm,
CDK code, it's generating YAML code. What's
yeah,
actually running is the YAML output that's there. So your code does not exist while a deploy is happening, which means you can't say when the deploy is done and you have this output, you need to do this thing because your code's not even there. Whereas with Pulumi, it feels completely different, where it just feels like your program is the script that is doing the deployment. And that's like, that matches the mental model of I'm
yeah,
writing a program, it's going to run and do things.
yeah. Which again, like now that we're so far removed from it, you can ask these questions of like, why do you need that extra expressive step then? And it doesn't make a lot of sense. Like it almost seems like the trade-off isn't worth it in some cases if you're going to go that far. Because again,
Yeah.
as a programmer, like you're expecting programs to run in a certain way. And this very specific thing of no, it's actually just generating the thing that's going to later be run and also not even run on your computer, right? It's going to be run somewhere else. Makes a huge difference in putting layers between you and the resources that are being created.
Yeah. I think another thing we were able to tap a lot into is the extensibility of Pulumi, which is huge for us because we're, again, like an intermediary. So giving us tools to customize things, like we'll really take advantage of that. It was very hard in the AWS ecosystem to create custom resources where you need to spin up something that's not exactly represented by AWS. And it was a really hacky thing where it would first deploy your logic as its own Lambda function, and then it would like invoke the Lambda function during the deploy, and has resulted in, as you can imagine, like a bunch of different problems. Whereas Pulumi has these native concepts built in to kind of address the issue. Hey, we have providers for a lot of things, but of course, there's going to be some things that there are gaps for. Here are tools that you
Yeah,
can use to fill in those gaps that the dynamic providers and things like that. So we were able to really take advantage of that to fully customize the deploy process. I think another nuance for us is if you are a DevOps team deploying something to production, there are certain things you optimize for. Like you want to optimize for safety and being able to roll back, and the things you care about are different than what an application developer cares about day to day. For your dev environment, you don't care about anything besides speed. Like you want stuff deployed as fast as possible. You want things to move on the moment you know that they're done. You don't need all the checks in place. So giving us that ability to customize how things operate in certain scenarios, yeah, we're able to take advantage of that a lot. And a lot of the speed improvements that are in STV3 come from that ability.
Yeah. Yeah, because in some level you're trying to ask this question, like this fundamental question of, yeah, why do we have such a large population of developers that are completely unaware of infrastructure as code? Like what's sort of missing here? And some of these concerns that we're trying to address happen to be our sort of answer to that question in some ways, right? So it really matters that we've got sort of control over like how the engine sort of operates, but also we've got visibility over the state that's being created, the resources, and the way they're being stored locally or on your side or on the user side. Yeah, I think, and the two put together, the fact that it is the program that's actually running, that we are able to extend it fairly easily, I think matters quite a bit.
Yeah. So I think a lot of our work to date has been just getting to parity with everything that we could do before, but like now do it in Pulumi and do it better. And we've definitely crossed that threshold maybe like a month ago or so. I think we were basically there. And now we've been able to really start to take advantage of the reason why we did all of this, which is we want to help people deploy anything, no matter what they're deploying, no matter where it is. And specifically focus on this application developer audience. And we've been able to do some really fun stuff. Like, you know, historically we focused entirely on like traditional clouds, AWS. Like earlier this week, we did a demo of like a bare metal deployment where, you know, you do things in a very like non-cloud way, and you can still use SST and the various providers to program it the same way you would program anything else. So I find that really compelling, and I think more and once people kind of have this idea click for them, they're just going to want to control more and more things this way, because we like the ability of having records of everything we've done, being able to like reproduce it, being able to create copies of it. Like we're very used to that with code, but for some reason people haven't realized that infrastructure should be treated the exact same way.
Yeah. It is odd. It's like once you start doing it, it just feels natural that you would want to do everything through there. And then I think to the point of the bare metal one, it's also interesting because when we were in the AWS ecosystem or completely in it, it didn't seem like it made that much sense that we would do something like this. But now that you've kind of opened the doors to any provider, it changed your mindset completely. You're like, wow, yeah, like the entire ecosystem is available to us. I think that is like very understated part of this, is that somebody could start with us but go effectively anywhere they want to go.
Yeah. And then that flexibility, the end user ends up taking advantage too, because that same friction that we felt, if you're mostly in AWS and there is a problem you're running into that's better solved through a different approach, if your tools can't access those, you have to use a completely different model, like you're just going to artificially weight that problem or weight that solution as, you know, worse when it's not actually. So now we're like, okay, this process, we can move it to like, you know, a traditional server, and it makes sense for us to do that. It's not as big of a decision because it just looks like the rest of our code. And yeah, some of these initial projects that I've built, I've mixed together, you know, AWS, Cloudflare, like even, I think people think of these tools as managing really traditional like infrastructure stuff, but we're also using it to manage things like our Stripe account, the configuration in our Stripe account, making sure that web hooks are set up correctly there. So yeah, I think people are still, as big as infrastructure as code has gotten and how it feels like, of course, everyone's heard of it. There's still a large number of people that are not doing this approach with anything at all. And I think being able to show them, hey, you can do this in these like weird places, I think it'll help them get the concept to click more.
Yeah, and it feels totally natural once you start doing it.
All right, so that's what we have for you all today. If you'd like to go check out SST, you can go to sst.dev. You can also follow us on Twitter, where we're doing a lot of really weird stuff usually, but I think you might enjoy it. But yeah, thanks for listening.